Welcome to Ask and Learn.
Hi all, Alex B here with another question on electrical resistance from Chapter 25 of Physics for Scientists and Engineers. So we're told that we have a wire which is going to measure strain, and the way it's going to do that is it's going to have some sort of unstretched resistance. R0 is equal to rho L0 over A0, where L0 and A0 are the unstrained length and area, and rho is just the resistivity of the material of the wire. And it's going to have some sort of new resistance, R, when it's strained, equal to rho, which we're going to assume isn't going to change, times L over A, where now L and A are the strained length and area of the wire. To calculate the change in resistance, we're just going to use the formula delta R is equal to R minus R0, which in this case is going to be rho, which we're just going to pull out since it's a constant, times L over A minus L0 over A0. Now we're told that when we're straining the wire, its volume is actually not going to change. So we have V0 is equal to V, or writing that out in terms of length and area, L0 A0 is equal to LA. Or, solving for A here, we're going to say A is equal to L0 A0 over L. Plugging that in over here, we're going to calculate then that delta R is equal to rho times L squared over L0 A0 minus L0 over A0. And using the same common denominator in both cases, we can pull out the L0 over A0 to find rho over L0 A0 times L squared minus L0 squared is our formula for delta R. Now, to continue here, we're going to need to expand L in terms of L0 and delta L, where L is therefore L0 plus delta L. Now rewriting our expression for delta R in terms of L0 and delta L, we should find that delta R is equal to rho over L0 A0, the same prefactor, times L0 squared plus 2 delta L L0 plus delta L squared minus L0 squared, where this all came from L squared. Canceling some terms that show up twice, L0, and this is a big approximation that we're going to use. We're going to assume that delta L is small, so therefore we could ignore delta L squared. Once we do that, this L0 cancels here, and we're left with delta R is equal to rho over A0 times 2 delta L. But we want to look at delta R over R0 and delta L over L0. So over here, we're going to divide by L0, and we're going to put it up here. But this itself is just R0. So finally, we're left with delta R over R0, which we've divided over from here, is going to be equal to 2 delta L over L0. Or rewriting it the way the question asks, we calculate that delta R over 2 R0 is equal to delta L over L0. Just the answer that we were looking for. But note that we had to use this approximation that delta L was small. Thanks for listening.